Good morning, students. Happy to see you. Today, we are going to see the introduction class of discrete mathematics. What is this discrete mathematics? Where we are using? Why we have to study? What is the objective of this course? For all these questions, we have a answer in this video. Okay. 20MA302 is a subject code. Name of the subject is discrete mathematics. Let us start the class. Today every one of us know that the world is full of modern computer science. Without this modern computer science we can't do anything. But the unknown factors, this modern computer world is fully based on discrete mathematics. Backbone of computer science, we can say discrete mathematics is the backbone of computer science. In particularly the discrete mathematics, it contains some topics, but in that particularly combinatorics and graph theory plays a vital role of modern computer science. Let us see how. First we understand what is the meaning for discrete. Discrete means apart or not connected set, and you can say they are distinct. And also mathematically if you want to say it's a countable. This picture shows that what is a countable? Yes, it's a 1-1 relationship. And we can say it's a not at all a continuous set. As I said, discrete mathematics is a very having a very good application in computer science. But it is not a branch of mathematics like algebra and topology. We will see some examples, students, to understand. What is this? Discrete. Easily it is countable. As I said, countable. Counting. Number of pages in the book. Easily we can count it. How many pages are there? 1000, 2000, hundreds. Like that you can count, able to count it. Number of candies in the packet. How many candies are there in the packet? So it is countable. One example for countable set in mathematics, we can say it's a whole number. Whole number starts with 1, 2, 3. Natural numbers, integers. These are the example for countable set. Countable sets are nothing but discrete. Easy to understand. We will see a real life example. Sound pitch of piano. Sound pitch of piano. Yes, piano. The sound we get it, we call it as it's a discrete. The sound pitch of violin. If you see that, the sound pitch of violin is continuous. So we'll see some more examples to differentiate what is discrete and continuous. Discrete means it's individual data. Continuous means it's a data remains or present in a certain range, in limits, certain limits, within the limits. How many datas are there? That is called it as continuous. Discrete means we can take individual values. Some examples: number of pages in a book. And what is the shoe size? If you want to check the shoe size of our class students, is each and every person is having a different, but still it is not in between the range. If you want to consider a temperature of the students in this class, so definitely it will starts from 90, for example 95.5 to 100 degrees Celsius. Within that the temperature will present. So in another example, how many persons are in race? How many students are going to take a race, or number of peoples in a race? Okay. What about here in continuous? Time taken. Time taken is not able to say it individually. it has to taken in a limit. So easy to understand. Discrete means individual values. Continuous means within the limit or range. You can take any values. What are the topics we have in our discrete mathematics? Logic and proofs, combinatorics, graph theory, algebraic structure, lattice and Boolean algebra. These are the topics. As I said, these topics we put it as a diagram. In first logic and proofs, we have the mathematical induction method. So Venn diagram is representing set theory. This key is representing the cryptography, graph theory, and the last one is algebraic structures. Same thing, these are the sentence or these are the terms we are going to use it in our different topics. Okay, let us see some examples where we are using this discrete mathematics. Why? Why is it important? Where I am using? Every one of us know that Rubik cube game. Rubik cube game is easily arrangeable? No. If you do the practice, you can arrange it. So some kids are doing very well, no, this Rubik arrangements. So maximum they are saying 26 steps only needed to arrange it. We are talking about the arrangements. Arrangements comes under in permutation. It's a very important topic in combinatorics. So arranging the numbers, arranging the colors, everything is based on the permutation. Another example, mathematics of paper folding. It's a very interesting game, paper folding game. But without knowing the basics of planar graph, we can't do this correctly. Paper folding plays a major role to cut the sheets, metal sheets, or to design, frame, everywhere we are using. So for that and all, we need planar graph. That's the base of this paper folding. It comes under graph theory. Why we need this discrete mathematics? How the Google is search very fast. So that internet, we know that how they are connecting that is comes under in graph theory. How we are connecting, that is very important. Then only you can able to take the data very fastly. That is designing the computer system. How they are designing efficiently the computer system. What is the security? Internet security, password, privacy, all those things are comes under in cryptography. Okay, so without knowing our discrete mathematics, this is not at all possible. So designing a computer system in an efficient way, you have to learn discrete mathematics. Some of the subjects we are using this discrete mathematics, or we can say discrete mathematics is a base for these subjects. Compiler design, data structure, database, parallel computing, distributed systems, cryptography, networks. It's going on, students, going on. There is no end. Here, what are the basic things they are using all these subjects? Logics. They are using logics, number theory, computing, graph theory. So these are the topics which I showed already in the before slide. These are the topics we are going to study. So these topics are the base for all these subjects. Let us see what is the objective of this course. Why this course is designed like this. You want to validate the arguments, whether my argument, whether my statements, prepositions is having some connectivities is right or wrong. Using rules of inference, we can show that. And next is develop the knowledge on the basis of counting. Counting is nothing but how we are going to count, how we are going to arrange, how we are going to select. All these are comes under in permutation and combination. How to solve the relations, recurrence relations, everything. Demonstrate the fundamentals. Graph theory, as I said, it's a very important for our networking. So what is the fundamental of that? And also we are going to find the relation between functions, relations and group theory. And also we are going to learn or familiarize the concepts of lattice and Boolean algebra. So once you started to study this course, these are the things we are going to learn. And I'll just explain what is the first unit. Logic and proofs. How do computers think? This comes under our logic and proofs. How do computers thinking? It will think only use of zeros and ones. How they choose that zeros and ones? From the logic, proportional logic. Once you started that subject, the proportional logics means it's a statement. The statement has to give only the answer either true or false. We call that as a proposition. The statement which has to give the answer only as true or false. True means 1, false means 0. So in this way only they design how the computers is thinking. And also this diagram shows that it's a dominoes game. What is the base of this game? Where I am using? The base of this game is the first domino is falls on the second one, automatically it falls on the third, fourth, fifth, like that. From this, what I understood, if my first case is true, then second case, third case, almost all our cases are true. This one is explained in mathematical induction method. What is the purpose? I want to study this mathematical induction. Yes, very important. I want to check that, verify that my loops are correct. Nested loops are correct. If my first loop is correct, then I can say second, third, everything is correct. Where I am using this logics and proofs? Artificial intelligence, AI, database, circuit, algorithms. In all these cases, we are using this logics and proofs. I hope students, first topic is well known to you now. Let us see the different, what is the second topic and third, and where we are using, how they are used in our syllabus. Thank you. I hope this video is useful to you.